Hello, my name is Steve Simpson, and I'm a Salesforce certified technical architect and architect instructor. And I'm sharing with you my architect insights on this YouTube channel, SteveTechArc, and my website, SteveTechArc.com. This is in my integration series, and today we're talking about cracking the code, Steve's number of zeros, in estimating integration volumes. When you're in the design phase of an integration, moving data between two systems, a key element is understanding how much data will go across. That will help you scale, choose the appropriate mechanism, and scale the appropriate components. And if you're using an integration layer such as MuleSoft, it can be very important to eventually get down to key metrics like transactions per second. So we're going to be talking about how you can start with rough business guidelines and then be able to come into some estimations. So estimating data can be very important. Calculating the integration traffic is very key. So first, you want to get the business to agree on baseline assumptions that they can understand and commit to. So you need to be able to be speaking the language that they're speaking and get them to produce some numerical values. Now, if they can't give you these numerical values, then I follow the Steve's number of zeros. I say, are you looking for 10 of these, 100 of these, 1,000, 1 million, 10 million, 10 billion? You can go from clearly under the level to absurdly above. And eventually you should be able to get them to give you a number of zeros. Do you have 10,000 records, 10 million records? And what you're going to do is you're going to convert them to, come up with that number, aim slightly higher if you have to. And you need to convert these numbers into industry standard units of measurement that can be used to estimate an integration. Some of these numbers you're really going to need to get to is going to be TPS, transactions per second, records per second, bytes per second, and what is the activity duration? Is this integration activity sustained over 24 hours? Is it peaked over 1 hour? And that's what's going to be very important to planning the integration. Here is a sample template that I put together that I've used in other implementations. So you're going to have inputs, number of transactions, number of records, average size and bytes of the transaction, number of hours. Ultimately, we're going to zero in on a per day activity. How many transactions per day, per records, average byte size, and the number of bytes, megs, and gigs in a day. Then we're going to determine the activity window. Is this going to be for 8 hours of activity, 12 hours of activity, or maybe 3 or 4 hours of activity? And so this spreadsheet is a nice little spreadsheet I'll use, and we're going to walk through a couple of examples. So here is a business activity. Transfer closed opportunities in an ERP in near real time with a flow. And in this particular example, these are the clear business requirements that you can ask for. Number of accounts, and the business may say 100,000. And we're going to be talking about, in a monthly category, how many opportunities close in a month on average per account. So if they're looking at closing 1 per week, I put 4. We don't need 10. We can just get to a nice clear number the business agreed to. Now we have number of records per opportunity. This could be the line items. So they may have an average of 10 line items per opportunity. And then we're going to look at all of the data associated with that in those 10 records on the top level opportunity. And if we get to, this is 1 meg. Now we could have easily adjusted this. Let's say they say it's smaller, it's 50K. So there's 50K bytes. And then in 1 month, by doing the math, we're going to end up with 400,000. Let's put some commas here. And we're going to go calculate the number. We don't need the decimals. 400,000 transactions in a month. We have 4,400,000 records with an average byte size. And what we're going to be doing is we're going to be converting this month into a day, and there are approximately 22 working days in the month. We're going to assume that these records only come across in the working days, and then we're going to feed in our inputs. We're at number of transactions, which you'll see is C13 divided by C18. So it's the total number of transactions divided by how many working days in the month. We're going to take the number of records, which is the total number of records divided by 22. And we're going to take the average size, which is here. And we're going to assume that these records only come across when the business users are closing the opportunities. And we found that there is generally a 6-hour window that they're going to be operating in. If so, we're going to come up with some daily numbers, number of transactions, number of records, average byte size. We're going to take those 6 hours and we're going to divide these by this factor. And this factor is the number of hours divided by 60, 60 minutes in an hour, 60 seconds in a minute. And we're going to now have a TPS, transactions per second. We're at 0.84 TPS with approximately 9.26 records. And we can see how many bytes and how many megs we are moving per second. So these numbers, the TPS, records, and average byte size, you could be giving to your integration team to project. Let's take a look at another business requirement. We're going to be looking at truck deliveries. And there are 1,000 trucks delivering 10 times per day. And they're going to be sending us notifications, an arrived notification, a status update notification, a job completed notification, and a departed notification. At each notification at the end on the job completed, they're going to send us 3 photos, average of 2 megs per photo. And so what we're going to do is we're going to take the 3 photos divided, but this is only on the job completed, which is 1 out of the 4 activity notifications. So I'm taking the 3 divided by 4 is the total number of photos per notification. And this will then come up with an average of 1.5 megs per transaction. Now, this can compute that we're at 40,000 transactions per day, 40,000 records per day, because it was 1 record per notification, the number of bytes. And we're going to then assume in this trucking here is at 8 hours. So we're assuming these trucks are working in one time zone and they're going to be delivering for 8 hours. And you can see we can get down to our daily activities and our TPS. We're now at 1.39 transactions per second. We're actually at a large number of photos. We're hitting essentially 2 gigs per second in photos. So that is 8 hours of the 40,000 transactions in a day with the average size of the number of photos and the bytes. So this particular integration has a 1.39 TPS, but a significant amount of data being transferred in the photos. And this can be very helpful in doing your estimations for the photo pass-throughs. We could be taking a look at another integration, which would be the number we have in appointments being made through Salesforce. We have 1,000 stores, 100 appointments being made per day, and we're going to be sending a notification to the customers through the integration. We're going to let them know it's a day before your appointment, here's your appointment, the day of, and we're going to send you an SMS on your arrival, or you'll send us an SMS on the arrival. So that's 3 notifications, and for each one, we're going to be showing you the line items of the activity that you're doing. So we come up with 6 records per notification. That's the 5 items plus the 1 top one. And we're going to estimate 100,000 bytes for the notification. That includes the header, the line items, and potentially some comment fields. You can see we have 1,000 stores, 100 appointments a day, and 3 notifications. That's clearly 300,000 notifications a day. We have our number of records, we have our bytes, and we're going to assume that this business is stretched over Eastern time to the continental US. So it's going from EST to PST. And so that's an 11-hour range. The 8 for EST, normal working hours, plus the 3 for the PST offset. We get to our transactions, and now we can see that we're at 7.58 transactions per second for those 11 hours. We're moving the 45 per second, but we're actually low on the megs per second. We're only at 73 megs per second. So this doesn't have photos. This has just lower amounts of bytes, but we're at a higher TPS than the previous one, 7.58 transactions per second. So this would be very helpful for any kind of let's say a MuleSoft team to be scaling the cores appropriately. Now let's look at another assumption where here we're looking at cases sent. We have agents working cases, 500 agents, and they're taking about 5 minutes a case. So every 5 minutes they take a phone call, they have activity, and then they move to the next activity. So 12 is 12 5-minute slots in an hour. We're assuming that they have an 8-hour shift. We're forgetting about lunch. And we're going to say there's a total of 3 records updated. So these are very clear numbers you can get from your business. How many agents? How much are they doing? Every 5 minutes is a very straightforward assumption. Every 10 minutes, just what's the average call duration? And any call center should be able to provide those KPIs for you. And what's the size of the average transaction? From here, we can do our math, which is the number per day. And we're up to 48,000 transactions per day, which we can kind of do the sniff test, 12 times 500 times 8. And you'll see that that's these numbers, C5, C6, C7. The business can buy into this. And then from there, we have our number of bytes, and we're saying an 8-hour duration. And then we can get to total number of transactions, 8 hours. And now we're looking at a TPS of 1.67. Only 4 records per second, and low bytes. You see we're looking at approximately 16 megs a second. This is another high activity, low number of bytes per second flow. These are ways in which you can take business assumptions in the green and do the conversion into the blue for your TPS and bytes per second transaction. Again, if you're not sure of a number, go to the number of zeros. In this particular case, they knew 500 agents. This is just every 5 minutes. And just how many hours a day. And if you can't be sure about the bytes, take a stab by the number of zeros, 10,000 bytes or a couple megs. So as we summarize, what you're going to need to do is calculating integration traffic is key early in the project. Making sure you're following in Salesforce. You want to make sure you're not going to exceed limits. Talking about integration components, you're going to need to scale the appropriate components. And this comes out with a smooth load across what I call the activity window. Estimation of peak, meaning like if within your 8 hours, there's a burst when there's a higher activity, will need to be done by the integration team. They can dive into that. And understanding the details of the implementation, such as queues and workers, will be key for the integration. So these are some of the methods that I use when I'm faced early on a project and I need to take abstract business requirements, but yet at the same time be giving concrete details to my integration team. So take these approaches, create these kinds of assumptions, do your computations, and then feel free to share them with the teams. And that can quickly become the baseline for those estimations. I hope this was helpful, and keep estimating. Thank you for diving into the tech swimming pool. Look forward for more surprises ahead.